Hey guys, here's our last video on index laws. What we're going to be talking about today is powers of products and powers of fractions. Before we get into it though, I've got a quick getting better at maths question for you. Which of the following expressions is equivalent to 2 times 5m plus 1? I'll get you to pause the video for a second and think about your answer to this question. Okay, hopefully by now you've had a go at answering this question yourself. If you remember back to when we did algebra, we take the 2 and we multiply it by both things inside the brackets. 2 times 5m is 10m and 2 times 1 is 2, so this is the answer. Right, again guys, I want you to pause the video here and attempt these two questions. They are a revision from yesterday's class. You should be able to answer these. So let's deal with the numbers first. 24 divided by 8 is 3. Now, when we have x to the power of 4 to the power of 6 again, we do 4 times 6 here. Sorry, that's not an x, that's a times. And then down here, when we have x to the power of 2 all to the power of 3, that can become x to the power of 2 times 3. So we have here 3x to the 24 over x to the 6, but now we have x to the power of something divided by x to the power of something, so we can subtract these two and we end up with which is 3x to the 18. Okay, and now in the second example, 25 divided by 21, we can divide 7 into both of those numbers and end up with 5 over 3. And now we have a 2 times 3, 0 times 3. So we end up with 5a to the power of 6. Now, something to notice here is we have a 0, which means our a term on the bottom is just going to go to 1. So our answer is 5a to the power of 6 over 3. Alright guys, now we're moving on to our new content for today. What we're going to be looking at is powers of products. Here we have a product, 2 times x cubed to the power of 2. Now, what happens with this? Because everything here is raised to the power of 2, what we can actually do is we can write this like this. 2x cubed all to the power of 2 is the same as 2 to the power of 2 times x cubed to the power of 2. So what we've done is we've taken each individual thing inside our brackets and we've raised it to the power of 2 over here. So now we can simplify this. Remember, we just revised this. So this is going to end up being 4x to the power of 6. Now, the other new thing we have to do is look at when we have a fraction here. X divided by 3. And the whole thing is to the power of 4. So similarly to the first question, we can actually take the thing on the top, make it to the power of 4, and take the thing on the bottom and make it to the power of 4. And that is actually as simple as we can make it. Because we don't have the same base, we're not able to subtract the indices. All we can do is make it x to the 4 of 81, which is 3 to the power of 4. So here are a couple of examples for you to practice that. I'll do the first one. We've got 3 times 2 squared, all to the power of 3. So remember, we just attached now the power of 3 to both our numbers inside the brackets. 3 cubed times 2 squared times 3. So that will just end up being 3 cubed, which is 27, times 2 to the power of 6, which is 64. And if you want to put that in your calculator, the answer comes out as 1,728. I'll get you guys to pause the video and attempt B by yourself, please. Okay, now hopefully you've had a go at this. Remember, when we expand it out, we take this 2 and attach it to each of our terms inside the brackets. And we end up with 81a to the power of 6. Now again, when we have fractions, we take our power outside the brackets and we apply it to all of our terms inside the brackets. So we end up with this. Now our base is different, so we can't simplify the indices anymore. 2 is a different number to 5, so this has to stay exactly the same as it is right now. The question asks us to leave our answer in index notation, so this is our final answer. Alright, can you guys just pause the video and have a go at part B by yourself, please? Okay, and again, we just take our power outside the brackets and apply it to both our terms inside the brackets. And again, we're leaving our answer in index notation. Okay, so now what you guys are going to do is go to the textbook on this page and answer these questions, please. Thanks, guys.